do it.
Chairman, please.
Okay, so
The
red oval circle, you talk too much. Okay, I heard you. The red oval circle is showing us where the exposure station is. The red arrow dropping down is the vertical. Okay. This is the focal plane where I've put a lot of arrows. Okay. Okay, so that's it. And then point A is a point on the ground. It's supposed to have a set of coordinates, capital X, A, Y, A. Are you getting me? And then on the photograph, we have smaller X, A, Y, A. You see how easy it is? People go into photogrammetry exam, they just can't even, but you can see how simple it is. You ask a simple question, answer is funny and it's wrong. Okay. I want everyone to get 80 in this class. Get an A in this photogrammetry to prove a point. Are you agree? Okay. Now flying height is H, and then the difference between the height at point A and the flying height is H minus H, which we can actually put a subscript H subscript A, as we have learned. So put that in your mind. All right. Now we have the representation of R on the photograph to be R, smaller letter R. Are you okay? Okay, so smaller letter R here is to the top. Okay, and then we can also say that where is the point O on the ground is this point. So here to here is capital R. So from here to here. So where is A prime on the ground? Are you okay? Where is A prime on the ground? So who can tell us where is A prime on the ground? If A represents capital A, where is A prime on
so the A prime is the H, the small, where the small H is at the datum, where the small H meets the datum.
This place?
Yeah.
That's true. That's correct. So that place is like exposure. So it means that within this space, we have something is happening here. It is this whole mountain here.
Okay. That has been represented
exactly
as A prime
on here.
and A.
Exactly. So what it means is that if you had a building, the building will be tilting on the photo because it will be lying down. Are you with me? Flat.
Okay.
Where a photograph is flat. Okay, so I rest my case. So it means we understand R prime, and then capital R. In fact, we may not use capital R. We also know H, what H is, and we know capital A. With that understanding, we are just going to use two formulas. Are you okay? All right, so let's move on. Okay, let's start with this. The difference between the R and the R prime. In fact, what is R? R actually is the radial distance. Okay, call it radial distance.
That's the capital R.
Smaller R.
Smaller R. Sorry.
Capital R is the representation of R on the ground. Okay?
Yeah.
All right. So it actually tells something. It means R over R is a scale. But if I want you to think outside the box, you're a university student, so everything, let's think outside the box. Anything is possible. It means R over R is a scale, but we are not interested in that. In this lecture, that's not our focus. We will never mention R over R anyway in this course. All right, but I want you to understand that R is on the image and then capital R is on the ground. Okay.
On the ground.
Yes. Now, the difference between R and R is the displacement. So when R is equal to R prime, what is going to happen, guys? When R is equal to R prime, what is going to happen? What is the implication? D is equal to what?
Zero.
And what does it mean on the photograph?
It
What's
means
going to
whatever
happen?
is in the photograph is a true representation of what's on the ground.
No, not really. That's not what we want to see. It means there's no displacement. It means the building is no longer tilted on the photograph. It means we are seeing the apampem. We are seeing the top, the plan of the building. Are you with me?
Yes.
The top of the building. We are seeing the top and we are not seeing the side. Once we are seeing the side and we are at the top and we are looking at it vertically and we are seeing the side, it means that there's a displacement, a relief due to what? Relief. Okay. I'm building a point. Is that okay? I hope we are on the same page. All right.
Yes.
All right. Then again, there's a proof, but I don't waste your time on the proof. We can do similar triangles again, scale relationships. Remember, I said that R prime over this is scale. R over R is scale. Do you remember that? Do you remember? Do you remember the formula for scale? David, are you there? David?
I'm here. I'm here.
Yes. So, David, you can see that the left-hand side. David, are you bored?
No, sir.
Okay, that's fine. Anyway, I'm the boss here, so you can be bored. David, do you remember that this is a scale? This is also scale.
Yes, please. I remember.
And so I just said that R over R is a scale. Do you remember? I just said that just a second ago.
Yes, please. You said it.
So it makes sense to equate this to that, right?
Yeah. Yes.
Now, but there are two different scales. Clearly, this scale, the left-hand side one, is for what? Undulating terrain or variable terrain. And then the right-hand side is for what? A flat terrain.
Flat terrain.
What does it mean? We can use the left one literally to find the height of objects. Are you okay? That's the essence of what we are saying. So let's go straight to look at the derived relationship. In fact, we can prove, in fact, don't worry yourself about these proofs. We can do it for fun, but I'm not going to ask you to prove anything. We can prove that the displacement, okay, so the most important formula in this section is D equal to RH over capital H. Okay, the most important formula here is D equal to RH over H. Okay.
Yes, sir.
So, but we know what R is, don't we? How do you measure R? How do you measure R? Aerial photograph. Anybody to suggest how you measure R on the photograph? Anybody?
Please, can we see the diagram?
I want us to go back to the sketch again, right?
Okay.
Okay, let's go back to the sketch.
Sketch.
Okay. This is the sketch. But the question again is, how do you measure small letter R on the photograph? How would you do that?
The origin.
You do what?
You measure from the origin.
Yes.
That's the y.
You measure from the principal point. You don't call it the origin.
Point, yeah.
So
okay.
if you go and say
point.
origin, everybody will know that you are not serious. Are you okay? So always use the what? Principal point. Are you okay?
Yes, sir.
The
You measure from the
principal,
principal point.
yes, the principal line comes to the principal point from the perspective center. Is that okay? Great. So that in
Yes.
this, I'm going to show you my whiteboard. Can you see my whiteboard? Okay. In this diagram, the principal point is the center, the intersection of the y-axis and the x-axis. The center. Are we good? Okay.
Yes.
Great. So let me do this. I hope it works. In this particular photograph, okay, if you want the R for a point, so let me get something. Oh, where's an annotation when you're looking for one? Okay, let's do this. If I want the R for this, can you see the red dots?
Yes.
Okay, so according to, I don't know, Dave or something, Dave or someone said it, that we measure from the center. Who said that? Was it Dave?
No, Jonathan.
Okay, Jonathan is so right. So let's assume this is the center. This is R. It's called the radial distance. Are you okay?
Yeah.
You can measure so many of them. In fact, the most errors on a photograph increase or varies with the radial distance. Are you okay? So as you move away from the center, a lot of errors accrue. Are you with me? Okay. Now let's look at the two R's. Now this photograph we're looking at seems to be a very good example for what we are trying to do. Why am I saying that? Because I'm trying to look for the bottom of a high-rise building, and that will serve as R prime. Then R will be the top of the building. Okay. Okay, so if I take a building like this one, the top, yes, I can see the top, but the bottom, you can see that if I want to look at the top and bottom, the line will be the same line to the same point. So D is going to be approximately 0. What it means is that for most ideal situations for vertical photograph, D should be 0. Because R, okay, and then R prime will be approximately the same. Okay, I've drawn two lines, okay? One of the lines, the two of them are coming from the center of the photograph, and they are supposed to go to the bottom and the corresponding bottom top of an object. The object in question here now is the building. Are you okay? Now, so I've sent the first line over, and I'm bringing the second one. Now, when I took the first one, the top of the building and the bottom seem to be at the same place. Are you with me? Stay with me.
Yes, sir.
Okay, so what does it mean? It means that the distance R and an R prime are going to be approximately the same. R is going to be approximately equal to what? R prime.
R prime.
Which actually means that D is approaching what? 0. Which is the ideal case that we want. In that case, it means that there's not much error due to what? Belief. Okay, so quickly, let's look at the formula again. So the question was what? How do you
measure
R, isn't it?
Yes.
I think now we know how to assess it. Okay, now this formula, there are two of them. There's this one and then this one. Okay. What's the difference between R prime The formula with the R prime and the formula with R.
So the R prime.
Allows
The
us
R
to.
prime.
Hmm.
Hello.
Yeah, I'm listening to you. Go ahead.
I think the R prime is on the photograph.
No, the R prime is to the bottom of the object. The R prime
The
is a measurement to the bottom. Remember, are you the same, Jonathan? Are you the same person who said that we can get A prime at the bottom, right? H.
Yeah.
Very good. So the same thing. So that H is what we are seeing over here. Compared to the formula on top, you can see that there's a slight difference between the two. When we use R, we don't subtract HA. Meanwhile, when we introduce the R prime, then we subtract it. Okay. All right.
Okay,
so
sir.
yes.
Okay. All right. I think I get it.
Okay. Great.
I get it.
All right. So we observe that the amount of relief increases further. The point. Okay. This English doesn't make sense. The point is with respect to principal. Okay. So the farther the point is from the principal point, the relief, the amount of relief increases. Okay. The first one, the greater the elevation, the greater the amount of relief. That also makes sense. If you have a very tall building, you are likely to have some relief in there. Increasing flying height decreases amount of relief. It makes sense to me. If you've traveled from Kumasi to Accra before, you see that all the buildings tend to look flat. As you go higher and you go over some villages, everything seems flat. Okay. All right. So for elevations above datum, displacement is outward, while elevations below are displaced inward. Okay, so we need to take note of that. And take note of this statement. I'm going to go back because of that statement. Inward and outward displacements. Okay, so in this case, for an object that is above the datum, the displacement is outward. Are you getting that? You see that it's up to outward, yeah? Meanwhile, if the displacement were below the datum, then the displacement will have an inward displacement. So intentionally, let's draw something here. Let's put the point A down here. So if you put a point A down here, you can see that the displacement is going inwards. Okay. Because the bottom were here, isn't it? So we are going.
Yeah. So, sir.
Yes. So this is the bottom. The bottom of the object is here. The top is here. Okay.
Yeah.
But in the case where the object is below the datum,
yes,
you can see that we are going inside. Okay, your question. You have a question on that?
Yes. So the datum would be established before you take off the flight. You establish the datum on the ground. Right?
Datums are just assumed normally.
Yes, assume.
No matter
So
whether you do it before or after. Are you okay? Plug in the laptop for me. Plug in the laptop for me. Plug it in. So yes, it's not something that you do, but normally a datum is chosen. Are you with me? Okay. So in the case of
a particular,
let's look at relief this way. Let's look at relief this way. When I took the photograph, the building tilted. Is that also?
Yes. Okay.
But the building is only an example of a relief. What are the other examples of relief we can have?
The topography, let's say.
Exactly.
The topo can change, can tilt. Exactly. You're looking at it in a different way.
Exactly. So it's quite relative. Is that also?
Yeah.
It's quite relative. Okay. And it's quite tricky as well.
And it means your datum should be captured in your area photograph, right?
Not really, but there seemed to be some sort of datum with respect to the displacement. Because without a datum, inward and outward may not come in. Is that right?
Yes, yes, yes.
So let me just say that if this whole area were, oh, it's not charging, please. It's not charging. My niece is helping me here. She's my teaching assistant. Please make sure it charges. Plug it in, check the light on the thing.
It's on. Oh.
The light on my thing. Oh, can you help her? Oh, the light is not coming, so what do you do? The laptop is going off. Switch it on.
No.
Oh, Nyamido.
No,
Shake it a bit. When it comes there, you move away.
Sir, our time is almost.
it's on.
Thank you. Sit down. What do you mean by your time is almost? I don't get it. You have another lecture. Do you have another lecture? Or is it? Do you have another lecture? Someone said our time is almost. Who said that?
Yes, sir, it's me. We have another lecture.
Oh, okay. So we will
11
end it.
o'clock.
We will end it, yes, but next time let's start early. Is that okay?
Yes, sir.
Because we haven't done anything. In fact, the reason we met today, we haven't been able to do even half of it. So you can imagine that we need to probably make time. Otherwise, at the end of this, you are going to be asked to do the same work I expect you to do. We haven't done much today.
Yes, sir. So please, when you are done, kindly send us the recording
Don't
so that
worry
we can
about that.
follow.
Just make sure next time I have a reason I'm recording. Just make sure you come early and we can do a lot. That's why
We'll do
we'll
that. Yes, sir.
okay. All right. So
Sir,
all the
thank you
best.
so much. Sir, you are done. We really appreciate your time and sacrifice.
Okay.
Can I say bye?
Yes. My niece wants to say bye-bye.
Bye-bye.
Yeah, bye-bye. Thanks so
We'll
much.
buy something for her next time.
Okay, they'll buy something for you next time. What do you say?
Thank you.
And you are saying yes.
Yes.
Okay. Bye-bye then.
Okay.